Hello everyone, welcome to the numerical methods class. Today we will talk about chapter 6, which is again some approximation methods for finding the roots of equations, but this time we will talk about the open methods. And open methods are different from the bracketing methods, and we will see the differences as well. Let's start with the differences and similarities between the bracketing methods and open methods. So the bracketing methods that we learned in chapter 5, if you remember, they require two starting bounds, a lower and upper bound, which actually bracket a root. And it is convergent because it is always bounding the root between lower and upper bound. And you can see over here, for example, the lower bound and upper bound, and root is here. And then the upper bound is reduced and root is again between them. And lower bound is reduced and the root is again between them. And it actually eventually reaches to the the root, which has a very narrow bound, so that we can always find the solution. In the open methods, on the other hand, we can have only one starting point or two values without bounding the root. So these are two options for different methods in the open methods. And the reason why we don't need a bounding root or bounding values like the bracketing methods, because we are using derivative of the function as an information to continue on finding the root. And it may diverge because it is not bounding the root. So we are just simply starting from one value or two values to the root, and that's why it may diverge and it doesn't bracket the root. So, but when they converge more quickly than the bracketing methods. You can see here, for example, an example. We started with xi, and in the I plus 1 iteration, the second iteration, instead of going here, it went up to here, and it diverged. So it didn't go to the root, basically. Here, for example, the first point was here, the second was here, and the third is here. So it converges quickly to the root easily. So if it converges, it is converging faster than this bracketing methods. We have 6 open methods that we are going to introduce in this slide or in this chapter 6. These are fixed point iteration method, and basically in that we are just giving an x value as a function. Newton-Raphson method, we are using the derivative information in this. Second method, or it is called linear interpolation, we are also using the derivative but the estimate of the derivative, simply the finite difference approximation of the derivative, because sometimes we don't have the function or the derivative of the function. That's why we need to use the finite difference approximation of the derivative. There is modified second method. In this we have a parameter that we use in addition to the second. And quadratic interpolation, this is simply the quadratic version of second method. And in here you can see we have like a long equation, as you can see here. So instead of a linear interpolation, we will have a quadratic interpolation. And there is Brandt's method as well. And this is a hybrid method of open and bracketing methods, so that we can reach to the roots of complex equations easily by switching between the methods during the iterations.